For as long as we've gazed up at the night sky, one question has haunted humanity. Are we alone? The stars above are countless, and for centuries, people wondered if other worlds might circle them. Could they harbor life, perhaps even civilizations? For most of history, this was a question for philosophers and dreamers. But in the last 3 decades, science has given us an astonishing answer. Yes, there are other worlds. Thousands of them. We call them exoplanets, planets orbiting stars beyond our sun. And the discovery of these alien worlds has opened a new chapter in the cosmic story. This is the tale of exoplanets and the search for life beyond Earth. The first hints of other worlds before exoplanets were proven, science fiction imagined them. Writers and dreamers filled the galaxy with alien landscapes, but science had no proof. In the 20th century, astronomers began searching for wobbles in starlight, tiny shifts that might hint at unseen planets tugging on their stars. The task was daunting. Stars are vast, planets small. Seeing an exoplanet directly was like spotting a firefly next to a lighthouse from across an ocean. Finally, in 1992, astronomers Alexander Volschan and Dale Frail discovered the first confirmed exoplanets orbiting a pulsar, a dead neutron star. These were strange, lifeless worlds, but they proved planets exist beyond the solar system. Then, in 1995, Michel Mayor and Didier Queloz discovered 51 Pegasi b, a hot Jupiter orbiting a sun-like star. It was the beginning of a revolution. How we discover exoplanets? Since then, astronomers have developed ingenious methods to find these hidden worlds. The transit method: when a planet crosses in front of its star, it blocks a tiny fraction of starlight. Sensitive telescopes measure this dip, revealing the planet's size and orbit. NASA's Kepler Space Telescope used this method to discover over 2,600 planets. The radial velocity method: planets tug on their stars, causing a subtle wobble. By studying shifts in the star's light spectrum, astronomers detect this movement. Direct imaging: rarely, with advanced telescopes, planets can be photographed directly. This works best for massive planets far from their stars. Gravitational microlensing: when a star passes in front of another, its gravity bends light. If it has planets, they too affect the lensing, revealing their presence. Each method is like detective work, piecing together clues from the faintest signals in starlight. The diversity of alien worlds: what have we found? A universe more diverse and surprising than we ever imagined. Hot Jupiters, gas giants orbiting scorchingly close to their stars. Super-Earths, planets larger than Earth but smaller than Neptune, possibly rocky and habitable. Mini-Neptunes, small gas planets with thick atmospheres. Ocean worlds: planets covered in deep global oceans, potential cradles for life. Rogue planets, worlds drifting through space without a star, frozen wanderers in the dark. Some exoplanets have orbits of only a few days. Others take hundreds of years. Some are tidally locked, with one side an eternal day, the other an endless night. The sheer variety is staggering, reminding us that Earth is just one possibility among countless others. The habitable zone: the Goldilocks principle. Not all planets can host life. Too close to their star, they bake. Too far, they freeze. But there's a region called the habitable zone, or Goldilocks zone, where conditions might be just right for liquid water. Water is vital for life as we know it. So astronomers pay special attention to planets in this zone. But habitability is more complex than distance alone. A thick atmosphere can warm a distant planet. A runaway greenhouse effect, like on Venus, can doom a closer one. Magnetic fields, geology, and chemistry all matter too. The search for Earth-like planets is not just about size or orbit, it's about whether a world can truly sustain life. Famous exoplanets: some discoveries have captured the world's imagination. Kepler-2 to be the first confirmed planet in a habitable zone of a sun-like star. Proxima b, orbiting the closest star to us. Proxima Centauri, only 4.2 light-years away. TRAPPIST-1 system: 7 Earth-sized planets orbiting a tiny red dwarf star with at least 3 in the habitable zone. Kepler for 5 to be, sometimes called Earth's cousin, a rocky world 1,400 light-years away. Each of these worlds could, in theory, support life. Some may have oceans, atmospheres, even climates similar to Earth's. The search for alien life, finding planets, is just the beginning. The ultimate goal is finding life. Astronomers search for biosignatures, clues that life is shaping a planet's atmosphere. Oxygen in large amounts suggests photosynthesis. Methane could indicate biological activity. Water vapor signals potential oceans. The James Webb Space Telescope JWST is capable of analyzing exoplanet atmospheres, sniffing out these signs. In the coming decades, we may detect the fingerprints of alien life. But what kind of life? It may be simple microbes or something far stranger. Evolution on other worlds could follow paths we can't yet imagine. The role of future telescopes: the search is only beginning. Future instruments will revolutionize our view. Extremely large telescopes on Earth will image Earth-like planets. Missions like LOVEWAR and HABEX could directly study exoplanet atmospheres for signs of life. Advanced space interferometers might one day create detailed maps of alien worlds. For the first time, humanity is on the verge of answering the question, are we alone? The possibility of advanced civilizations. Beyond biology lies a deeper question: could there be intelligent civilizations? Projects like SETI listen for radio signals. Others search for technosignatures, the byproducts of technologies such as waste heat from giant structures. So far, silence. But the universe is vast, hundreds of billions of galaxies, each with billions of stars, many with planets. The odds are overwhelming. Perhaps civilizations are rare. Perhaps they rise and fall quickly. Or perhaps the galaxy teems with life, but communication is difficult across such distances. The Fermi paradox asks, if intelligent life is common, why haven't we found it yet? The answers range from sobering to hopeful. The philosophical impact: the search for exoplanets is not just scientific, it's deeply philosophical. If we find life, it means we are not unique. Life is a cosmic phenomenon. If we find intelligence, it could transform our place in the universe. If we find nothing, it may mean life is precious, fragile, and rare. Either way, the search changes us. It expands our perspective, humbles our species, and connects us more deeply to the cosmos. Humanity's role: we live in a remarkable era. For most of history, humans did not know other planets existed beyond our solar system. Now, in just 30 years, we have discovered thousands. And soon, we may find the first undeniable evidence of life beyond Earth. When that day comes, humanity will face one of the greatest moments in its history. It will remind us that we are part of something vast, ancient, and ongoing. Conclusion: the next chapter. Exoplanets have turned science fiction into science fact. They've shown us that the universe is full of worlds strange, beautiful, and mysterious. Some are infernos. Some are frozen wastelands. Some may be blue oceans under alien suns. And perhaps somewhere among them, life stirs. The question, are we alone, may not remain unanswered for long. With every telescope, every mission, every discovery, we are inching closer to the truth. The universe is whispering its secrets. We are learning to listen. And as we explore, we carry with us not just curiosity, but hope that out there, among the stars, we may one day find company. Because in the grand cosmic story, Earth is just the beginning. The next chapter is waiting to be written among the exoplanets. And that brings us to the end of our journey among the stars. From the first discovery of distant exoplanets to the incredible possibilities of alien worlds and the eternal question, are we alone in the universe? Every new planet we find is not just a scientific discovery, it's a reminder of how vast and full of wonder the cosmos truly is. Somewhere out there, orbiting a distant star, may lie another Earth. And maybe, just maybe, another form of life looking back at the stars. If you enjoyed this exploration, don't forget to like this video, subscribe to the channel, and hit the bell icon so you never miss our next deep dive into the mysteries of space. The search for life beyond Earth has only just begun. Together, let's keep exploring, questioning, and reaching for the stars. Thank you for watching, and I'll see you in the next cosmic adventure.